Hi everyone, how are you all? So in this session, we will discuss weekly quiz 26. In this weekly quiz, all the questions are from Stanford University. Okay, so the subject of this weekly quiz is theory of computation. In this weekly quiz, we have questions from finite automata and regular expression. Okay, so let's see the discussion. You can see all the questions. Every question is from the Stanford theory of computation course. So let's start now. Let's see this first question. Question number one. This is our question number one. So let's see this. Consider the following simple finite automata. This finite automata, this is given to you. Which of the following strings are not accepted by the given finite automata? The question is asking which strings are not accepted. Okay. Remember, the question is asking which strings are not accepted. So tell me which strings are not accepted by this finite automata. This automata is given to you. This Q2 is the final state. You can see this Q2 is the final state. And when can I say string will be accepted? To this finite automata, if I give some string, this is your finite automata M. If I give this string W, if I give this string W, then when can I say this string will be accepted? This string will be accepted if and only if when you read the entire string, at the end of the string, you must be in one of the final state. Yes or no? When you read the entire string, this is your entire string. This is the entire string W. Now, when you read the entire string, you should read the entire string. At the end, you must be in the final state. Okay? After consuming the entire string, you must be in one of the final state. Here you can notice Q2 is the final state. So tell me, this string, is it accepted? This string that is given to you, the string is 0 1 0 1 1 0. Is this string accepted? Let's start. You will start in the start state, yes or no? Okay, so let's start in the start state. In the start state Q0, this is your string. Remember, your string is 0 1 0 1 1 0. This is your string. You will start in state Q0. In state Q0, if you read 0, where you will go? In state Q0, if you read the symbol 0, you will go to state Q1. You will go to state Q1. In this state Q1, if you read symbol 1, where you will go? In this state Q1, if you read symbol 1, then you will go where? You will go to Q2. You will go to Q2. In this state Q2, if you read symbol 0, then you are going to Q3. Okay, then you are going to Q3. In this state Q3, if I read symbol 1, then I am going to Q0. Okay, in this then I am going to Q0. In this state Q0, if I read symbol 1, then I am going to Q3. Then I am going to Q3. In this state Q3, if I read symbol 0, then where I will go? In this state Q3, if I read symbol 0, then I will go to Q2. Now you can notice at the end where you are. You can notice at the end of the string, you are in the final state. So I can say, yes, this string will be accepted. This string will be accepted. Okay. So quite simple. This string will be accepted. Very easily you can see. Okay, at the end of the string, you are in the final state. At the end of the string, you are in final state. So I can say this string will be accepted. Let's see the next string. Let's see this string. This string, option B. What option B is saying? This is 1 0 1, then 000. What about this string? Is this string accepted? Your string is 1 0 1, then 000. You start in the start state. Always start in the start state. So you are in this state. In this state, if you read symbol 1, then where you will go? In state Q0, if you read symbol 1, okay, if you read symbol 1, then you will go to state Q3. In state Q3, if you read symbol 0, then you will go to state Q2. Okay, tell me one thing. I am going to state Q2 and Q2 is final state. So can I accept? Can I accept this string? I am going to Q2 and Q2 is final state. So can I accept? No, I cannot accept, because remember, at the end, you must be in the final state. At the end of the string, when you consume the entire string, after reading the entire string, you must be in one of the final state. Okay, so here I can say in this Q2, if I read symbol 1, if I read symbol 1 in this state Q2, I will go to Q1. In this Q1, if I read symbol 0, then I will go to Q0. In this Q0, if I read symbol 0, I will go to Q1. In Q1, if I read symbol 0, I will go to Q0. This is non-final state. At the end, I am in the non-final state. So this string is rejected. This string is rejected. What about the next string? Option C. Option C is 110, 111, then 00. What about this string? So let's quickly do. This string 110, 111, and 00. Always start in the start state. In this state, if you read symbol 1, in this state Q0, if you read symbol 1, you will go to state Q3. In this state Q3, if you read symbol 1, then you will go to state Q0. In this Q0, if you read symbol 0, you will go to state Q1. In Q1, if you read symbol 1, you will go to Q2. In Q2, if you read symbol 1, you will go to Q1. In Q1, if you read symbol 1, you will go to Q2. In Q2, if you read symbol 0, you will go to Q0. In this state Q0, if you read symbol 0, you will go to Q1. At the end, I am in the non-final state. At the end of the string, I am in non-final state. So this string is also rejected. This string is also rejected. What about the last string? The last string, that is your empty string. This empty string, remember this is a DFA. Remember this machine that is given to you, you can notice this machine is DFA. Now tell me when DFA will accept empty string. This point we know that DFA accepts empty string. DFA accepts empty string if and only if initial state is final state. If and only if initial state is a final state. Initial state is a final state. Okay, so this is if and only if statement. Remember, this statement is if and only if DFA accepts empty string if and only if initial state is a final state. You can see initial state is not final. Here you can notice the initial state. This state is not final. This state is not final. So I can say this string will be rejected. This string will be rejected. Someone is saying option C, that is accepted. Is this accepted? 110, 111, 00. Is this accepted? C, 110, then 111, then 00. Okay. Oh, yes, this is accepted. So this string, this option C, this is accepted because you start in the start state Q0. Then when you read symbol 1, you will go to Q3. In Q3, if you read symbol 1, you will go to Q0. In Q0, you read symbol 1, you will go to Q1. In Q1, you read symbol 1, you will go to Q2. You will go to Q1, you will go to Q2. In Q2, if you read symbol 0, you will go to Q3. In Q3, if you read symbol 0, you will go to Q2. Okay, so yes, this string will be actually accepted. This string, option C, this string will be accepted. Okay, so this option C will be accepted. And you can notice option B rejected, option D rejected, option A accepted. So what is the final answer? What is your final answer? Tell me. So for this question, what will be the final answer? So this is a very simple question. And for this, remember the question is asking not accepted. The question is asking which are not accepted. So not accepted means that is your B, D. Answer will be B, D. Okay. So this is your answer. So this is a very simple question for 1 mark. You can see this is a 1 mark question. Now let's move on. Let's see this question. Let's see this one. Let me tell you in this previous question, what mistake people can do? This is a very simple question. This is extremely simple question, but still, what mistake people can do? Tell me. This is the common mistake that people will do, that they will mark. This is a common mistake people will do. Very common mistake that some students will mark accepted. A, C. Yes or no? This is what some students will do. This is a common mistake that people will do. Is there anyone here who did it? Is there anyone here who made this mistake? So the answer will be this. Because the question is asking not accepted. But this is a common mistake people will do A, C. Because they will not read this not. Okay, this word they will not read. They will just answer which string is accepted. Okay, let's move on now. Now let's see this question. This is another very simple question. The question is asking which of the following statement is or are true. 4 statements are given to you. Which of them is or are true? So tell me. The question is asking a language of an automata can have an infinitely long string. Is it possible? A language can have infinitely long string. Is it possible? No, this is never possible. This is false. Okay, remember every string has finite length, correct? See, whatever string you notice what is your alphabet. See, first of all, you have alphabet. First, you have alphabet. This is your alphabet sigma. In this alphabet, you have, for example, these are the characters. You can call them characters. Okay, you can call them characters or symbols. You can call them characters or symbols. Okay, so these are characters. Now, from these characters, you can create a string. From these characters, you can create a string. What is a string? A string is a finite sequence of characters. A string is a finite sequence of characters. Yes or no? A string is a finite sequence of characters. For example, a string can be like this. You can notice this is a finite sequence of characters. In this, you have total. What is the length of this string? The length of this string is 6. The length of this string is 6. Remember, a string is a finite sequence of characters. So a particular string can never have length infinite. Okay. So you can notice a string can never have infinite length. Can never have infinite length. A string can never have infinite length. Okay, whatever string you take, that can never have infinite length. Is this clear? Very simple point. Okay. So this is the definition of a string. Finite sequence of characters. Whatever string you take, for example, this string you take, the length will be 0. Okay, whatever string I give you whatever string you take, you can notice the length will be finite. For this string also, the length, I can say the length will be finite. Okay, so very simple point. You can see the definition of string. A string can never have infinite length. Okay, so this option A is saying a language can have infinitely long string. Okay, what option A is saying? See, option A is saying that a language can have infinitely long string. Means the question is saying, this option A is saying a language can have a string which has infinite length. This string has infinite length. This string has infinite length. Is this possible? This string has infinite length. This is never possible. This is never possible. Okay. So very simple. This is never possible. So I can say that option A, that is false. What about the option B? A language can contain infinitely many strings. Here what we are saying, tell me. Infinitely many strings. A language can contain infinitely many strings. This statement is true. This is saying that a language can have infinite number of strings. See, understand the difference between these two. Infinite length string. Understand the difference between these two. Infinite length string and infinitely many strings. Infinitely many strings. Many strings. Please tell me, do you understand the difference between these two? Here we are saying infinite length string. A string with length infinite. This is a string. This is a string whose length infinite. Whose length is infinite. Whose length is infinite. This is never possible. Yes or no? Agree? Okay, so I can say this is never possible. This is never possible. A string always has finite length. Remember, whatever string you take, a particular string, any string you take, a string always has finite length. Always has finite length. Finite length. Okay. What this second statement is saying? This second statement is saying infinitely many strings. What this means? This means infinite number of strings. Yes or no? This means infinite number of strings. Okay, for example, notice this language. In this language, how many strings we have? Tell me. In this language, how many strings we have? Tell me. If I give you this language, how many strings we have? Tell me. In this language, how many strings we have? How many? Can I say we have 10 strings? In this language, can I say we have 10 strings? Can I say we have 10 strings? No. We have infinitely many strings. Okay, number of strings is infinite. In this language, we have infinitely many strings because the number of strings is infinite. Okay, is this clear? Please tell me, did you understand the difference between these two? You have infinite length string, that is not possible. Infinite length string, that is not possible. But infinitely many strings means number of strings is infinite. Okay, means number of strings is infinite. Number of strings is infinite. Okay, yes or no? Did you understand the difference between these two? Here string length is infinite. Here number of strings is infinite. Okay, and you can notice this language has number of strings in this language that is infinite. But every string has finite length. Yes or no? But every string has finite length. Whatever string you take, that will have finite length. That will have finite length. Okay, so very simple. Here you can notice option B, that is true. A language can have infinitely many strings. What about option C? A language can contain no string. Yes, that is also true. Yes, that is also true. For example, you can take this language. For example, this language you can take. Yes or no? This language you can take. Tell me one more thing. Can I say this language contains no string? Can I say which language contains no string? Tell me. Which language does not contain any string? Which language does not contain any string? Remember, this language does not contain any string. This language does not contain any string. This language does not contain any string. This contains one string. This contains one string. Okay, this contains one string. Remember, that string is empty string. That string is empty string. So this language contains one string. This language does not contain any string. Okay, so yes, option C is also true. A language can contain finitely many strings. Yes, this is also true. Okay, for example, you take this language. Okay, consider this language. In this language, you have only 2 strings. So you have finitely many strings. Yes or no? Okay, here you have finitely many strings. Number of strings is finite. Number of strings, that is finite. So please understand, when I say finitely many strings, what that means? Finitely many strings. What that means? That means number of strings is finite. This means number of strings. Number of strings is finite. Okay. Is this clear? So very simple. So finitely many strings, that means number of strings that is finite. For example, if you take this language, then this language has finitely many strings. Okay, because number of strings that is finite, number of strings is 1. Here, if you notice, what are the number of strings? Number of strings is 1. Okay, so you can notice number of strings is finite. So this is the idea. So for this question, what will be the answer? The question is asking true statement. The question is asking true statement. So what will be the answer? Answer will be B, C, D. Is there anyone who did mistake in this question? This is a very simple question. Still, some people have done mistake. Some students have done mistake in this question also. So the answer will be B, C, D. I hope this point is clear. So you can notice we have seen what is alphabet. Alphabet is finite non-empty set of symbols. Yes or no? This we have already seen. What is alphabet? Alphabet is finite non-empty set of symbols. Okay, you can call them characters. We denote it by sigma. Next, what is a string? A string is a finite sequence of characters. A string has finite sequence. A string has finite sequence. For example, this is a string. The length is finite. This is a string. Length is finite. This is a string. Length is finite. Empty string has length 0. We denote it by epsilon. And remember this point, you can notice string has finite sequence. String is a finite sequence of characters. You cannot have a string of infinite length. Yes or no? You cannot have a string of infinite length. Very simple point. Next, what is language? We have already seen language is set of strings. What is sigma star? Sigma star is set of all strings. Sigma star is set of all strings. And what is language? Language is set of strings. And every language is subset of sigma star. All these points we have already seen. You can notice language is set of strings. Language is set of strings. String is sequence of characters, finite sequence of characters. Okay. And what is alphabet? Alphabet is non-empty finite set of characters. This diagram you can see. Alphabet is a finite set. Every alphabet that is finite set, finite non-empty set of characters. String has finite sequence of characters. And language is a set of strings. This is your question. Tell me the answer for this question. This is another simple question from Stanford. Tell me the answer. How many of the following statements are true? The question is asking, how many of the following statements are true? Alphabet are sequence of characters. Alphabet is sequence of characters. No, alphabet is not sequence of characters. Alphabet is set of characters. Alphabet is a non-empty finite set of characters. Alphabet is non-empty finite set of characters. Yes or no? So alphabet is finite non-empty set of characters. So alphabet is not a sequence of characters. This is false. Language are set of strings. Yes, this is correct. Strings are set of characters. This is false. String are sequence of characters. String are sequence of characters. Yes or no? You can notice string are sequence of characters. String is finite sequence of characters. Finite sequence. String is a finite sequence of characters. Character are individual symbols. Yes. Languages are sequence of characters. No. Languages are set of strings. Languages are set of strings. Okay. So you can see this is your answer. Now let's move on. Now let's see this question. So this is our question number 3. The question is asking, how many of these are DFA over 0,1? This is a Stanford question. You can see this question is also taken from Stanford. So tell me the answer for this question. The question is asking, how many of these how many of these are DFAs over 0,1? How many of these are DFAs over 0,1? So tell me what you will check. What you will check in a DFA? In a DFA, what should happen? In a DFA, you have 5 things: set of states, alphabet, initial state, set of final states, and transition function. These are the 5 things. You can notice set of final states, that is subset of Q. Okay, that is subset of Q. That can be empty also. Yes or no? That can be empty also, because empty set is also subset of Q. Correct? Yes or no? So you can notice that can be empty also. That can be empty also. This set of final states, that can be empty also. That can be empty also. Okay, because you can notice empty set is also subset of states. You can see. So remember this set of final states, this is subset of set of all states. So very simple. In a DFA, what should happen? In a DFA, every state on every symbol, every state on every symbol, yes or no? What should happen? This should happen. Every state on every symbol, must have exactly one transition. Exactly one transition. Okay, very simple point. Every state on every symbol must have exactly one transition. So these are the things you should understand. Now let's see. Tell me the first one. Is this a DFA? The first one. Yes, this is a DFA. because every state on every symbol has exactly one transition. Every state, whatever state you take, every state on every symbol has exactly one transition. This Q0 has exactly one transition on 0. This Q0 has exactly one transition on 1. Okay, this Q2 has exactly one transition on 0. And this Q2 has exactly one transition on 1. So every state has exactly one transition for every symbol. What about this one? Is this a DFA? This is not a DFA. Why this is not a DFA? Tell me. Why this is not a DFA? This Q1 does not have any transition on 0. This Q1 does not have any transition on 0. This Q0 has no transition on 1. Okay, yes or no? This Q0 has no transition on 1. Okay, you can notice this Q0. This Q0 has no transition on 1. This is 5. Okay, so you can notice this is not given. Very simple. Okay, so like this you can see this is not a DFA. What about the third one? What about this third one? Yes, this is a DFA. Every state on every symbol has exactly one transition. What about this one? What about this one? Is this a DFA? Yes, this is a DFA. Every state on every symbol has exactly one transition. See, there is no final state. So can I say this is DFA? There is no final state. There is no final state. Does it matter? Does it matter? There is no final state. Does it matter? No, it does not matter. It does not matter. Here, what is the set of final states? Tell me. Here, what is set of final states? Tell me. Tell me what is set of final states. Set of final states, that is empty. Can I say that is subset of Q? Can I say that is subset of Q? Yes, that is subset of Q. Okay, is this clear? So you can notice this is a DFA. This is a DFA. Okay. Now, what about the next one? What about this one? This is not a DFA. Why this is not a DFA? You can notice Q1 has more than one transition on 0. This state Q1, this has more than one transition on 0. This state Q1 has more than one transition on 0. Okay, but remember, every state should have exactly one transition. Every state on every symbol must have exactly one transition. So I can say this is also not a DFA. What is the answer? What will be your answer? Answer will be 3. So for this question, the answer will be 3. Okay, quite simple. Now let's see the next one. What about this question? This is our question number 4. Okay, so this is another question from the Stanford University. You can see. So this is another question taken from Stanford. So tell me, what is the answer? This is the DFA that is given to you. Is this DFA? Is this DFA? No, this is actually NFA. This is not DFA. This is NFA. Remember, this is not DFA. Why this is not DFA? Why this is not DFA? Because state Q0 has more than one transition on 1. State Q0 has more than one transition on symbol 1. On symbol 1, you are going to Q0 also. On symbol 1, you are going to Q1 also. Okay, so this is NFA. This is not a DFA. Also, you can notice there is no transition from Q1 on 0. This state Q1 does not have any transition on symbol 0. This state Q2 does not have any transition on symbol 0, 1. So this is NFA, not DFA. So the question is, this NFA is given to you. What are the language of this NFA? The question is asking, what are the language of this NFA? This NFA is given to you. What are the language of this NFA? So you can write the regular expression. You can write regular expression, yes or no. What will be the regular expression? See, whatever comes, 0 or 1, whatever comes, 0 or 1, whatever comes, 0 or 1, whatever comes. When you will go to final state, see 0 or 1, whatever comes, 0 or 1, whatever comes, at the end 1, 1 should come. At the end 1, 1 should come. Okay, so I can say ending with 1, 1. So the language of this NFA, what is that? The language of this NFA that is ending with 1, 1. Okay, so remember the language of this NFA that is ending with 1, 1. So can I say this is the language? Can I say this is the language? Tell me. Option A. This is MSQ question. This question is MSQ. This question is MSQ. Multiple options are correct. So tell me. The question is asking what the language of this NFA. This NFA is given to you. Now, you know that this NF is accepting strings ending with 1, 1. So can I say this? Okay, tell me which statement is correct. This NFA that is given to you, NFA N. Okay, so you tell me which statement is correct. NFA N accepts string. This string, which string? 0, 1, 0, 1, 1. This statement is true or not? Another question I am asking. NFA N accepts language 0, 1, 0, 1, 1. Which statement is true? Tell me. Which of these statement is true? Two statements are given to you. Which of them is true? NFAN accepts string 0, 1, 0, 1, 1. Yes, this is true. Okay, this string is accepted. This string is accepted. Can I say this language is accepted? Can I say this language is accepted? This statement is false. Okay, this statement is false. Remember, what is the language? Language should contain all and only those strings which are accepted. Okay, remember this point. Remember this point, that language of N, okay, must contain is a set of all and only those strings. Okay, remember ln is a set of all and only those strings that are accepted by N. Is this point clear? Please tell me. Okay, this is a very important point. Okay, see, ln is set of all strings that are accepted. Set of all strings that are accepted. Set of all strings that are accepted. And only those strings which are accepted. Okay, so remember, this ln, this is set of all and only those strings which are accepted. You should have all those strings which are accepted, and you should have only those strings which are accepted. So all and only those strings which are accepted. Okay, so remember this point. So remember, this is not a language. Option A is not a language. This option A, this is not a language. Okay, this is also not a language. Ending with 1, 1, this is a language. This is not the language. Okay, so yes or no? This is, so your answer will be, for this question, what will be the answer? For this question, the answer will be option C. Option C will be the answer. Okay, so very simple. So don't make this mistake. Please understand that this NF is accepting this string. This string is accepted, but don't say that this language is accepted. No, language is set of all strings that are accepted. Language is a set of all strings and only those strings which are accepted. All and only those strings which are accepted. Let's move on now. Now let's see this question. This is another question from the Stanford, question number 5 in this weekly quiz. So this question is also taken from Stanford, you can notice. So tell me the answer for this question. So the question is saying, read the question carefully, what this question is saying. The question is saying that we transform the following NFA into equivalent DFA. Okay, this NFA is given to you. We convert this NFA into equivalent DFA using the subset construction algorithm. Okay, is this clear? See, this NFA is given to you. We convert this NFA to equivalent DFA using this algorithm, subset construction, or you can say power set construction, using this algorithm. Now, how many of these rows are marked as accepting state? This NFA is given to you. We convert into equivalent DFA using subset construction algorithm. Then you are getting this DFA. This DFA you are getting. Okay, this is the DFA you got. This NFA. This NFA is given to you. This NFA you are converting into DFA. This DFA you got. This DFA you got. This equivalent DFA you got. So which states are final? Tell me. Which states will be final in this algorithm? In this algorithm, when you convert NFA to DFA, which state will be final? That state will be final which contains at least one state which is final in this NFA. Yes or no? I can say, see, in this NFA, Q3, Q1 are final. In this NFA, Q1, Q3 are final. In this NFA, Q1, Q3 are final. So any state which contains at least one of them, any state in DFA, in this DFA, any state which contains at least one of them, that will be final, at least one of them. So I can say this state will be final. Yes or no? This state contains Q3, this will be final. This state contains Q1, this will be final. This will not be final. Okay, this will be final. It contains Q3. It contains Q3. It contains Q3. It contains Q3. So what your answer will be? Answer will be how many states, how many rows should be marked as accepting states? The answer will be 6. Okay, is this clear? Please tell me. Let me know. Very simple. In this subset construction algorithm, whenever you have some NFA, you convert that NFA to equivalent DFA. You convert that NFA to equivalent DFA using this subset construction algorithm. Using this algorithm, subset construction algorithm, then you can notice what will be final state here. So here I can say those state will be final which contains at least one final state of NFA. Yes or no? In this equivalent DFA, those states will be final. Or I can say that this will be final. If I give you some, okay, this, I can say this state. I can say this state, entire. Okay, I am talking about this state. This state will be final. When can I say this state will be final? Tell me. This state will be final. Will be final if, okay, if there exists in this I can say there is at least one state which is final in NFA. Yes or no? I can simply say that this state will be final. Okay, there can be more states. This state will be final if Q is final state in NFA. Q is final state in NFA. Okay, so like this. I hope this point is clear. You can notice in this NFA is given to you. In this NFA, Q3, Q1, these are final. Here you can easily notice that Q3, Q1 are final. This Q1, Q3, these are final. So in this DFA that you are getting, in this DFA, all those states will be final, which contains Q3 or Q1, So this will be final, final. Okay, those states which contain Q1 or Q3, at least one of them, those states which contain at least one of them, that will be final. So your answer will be 6. Let's see the next question. Now let's see this question. This is a beautiful question. Let's solve this question. This is our question number 6 in this weekly quiz 26. So this is a very beautiful question. Let's solve it. This is another question from the Stanford. You can notice this question is taken from Stanford as it is. So the question is very nice. Let's read this question and tell me the answer. What this question is saying. So this machine is given to you. Is this NFA or DFA? This machine that is given to you, this automata that is given to you. Yes, this is a NFA. Okay, this machine, this automata is NFA. The question is saying, suppose we run this NFA. This NFA we are running on string 10110. Okay, we are running this NFA on string 10110. How many of the following statements are true? How many of the following statements are true? Some statements are given to you. How many of them are true? Okay, so this is the question. I hope you understood the question. So the question is saying, how many of the following statements will be true? Okay, so let's see. So we are running this NFA. Let's run this NFA on 10110. Okay, let's run it. Your string is 10110. This is your string. Now, what is the first statement? There is at least one computation that finishes in an accepting state. There is at least one computation. Which finishes in accepting state. See, let me tell you one thing. This is your string, or if you take a simple string, let's take a simple string. In this, for this NFA, if I give you this string, for example, let's assume I give you 1. Let's assume this 1. Tell me how many computations will be there. How many computational paths will be there? Okay, for this string, if you run this NFA is given to you. If you run this NFA, okay, run NFA on W. Run NFA on this string W. Then tell me how many computational paths will be there? How many computations? Or I can say how many computational paths possible? How many computational paths are possible? See, these are the paths possible. You will start in the start state, yes or no? You will start in the start state. Okay, so let's start in the start state. In this start state, tell me what you can do. Tell me, in this start state, your string is 1 1. Your string is 1 1. You tell me one simple point. Can you take this transition? Can you take this transition from the start state? From the start state, can you take this transition? I am talking about this string 1 1. Okay, so let's take this string 1 1. Your string is, you start in the start state. This is your start state. Can you take this transition? Can you take this? No, I cannot take this transition because remember our string that we are taking, that is WW. We are considering this string 1 1. This is our string. Okay, so tell me which path will be there? There is only one. There is only one path, that is you have to make null move. Yes or no? Yes or no? So from the start state, you have to make null move. You have to make null move. Now where you are? Now you are in this state Q1. Okay, now you are in this state Q1. So let's call it Q1. Now you are in this state Q1. You are making a null move. This is a null move. You cannot, this is a null move. Did we consume any symbol? Did we consume any symbol? No, we did not consume any symbol. Now from this state Q1, where you will go? There is only one way. Okay, there is only one way. From Q1, you have to go to Q2. Okay, from Q1, you have to go to Q2. Now, how many symbols you have consumed? Yes, one symbol consumed. Yes or no? Now, one symbol consumed. Okay, now where you can go, tell me. Now, where you can go, let me know. Now, where you can go. You are in Q2. You are in state Q2. Now, you can notice from Q2, either you can take a null move or you can read the symbol 1. From state Q2, this is your Q2. You are in state Q2. In this state Q2, either you can take a null move, or you can read symbol 1. If you read symbol 1, where you will go? If you read symbol 1, you will go to Q3. Yes or no? If you read symbol 1, you will go to Q3. Agree? If you read symbol 1, you will go to Q3. Can you go anywhere from Q3? Can you go anywhere from Q3? Remember, from Q3, can you go anywhere else? No, you cannot go because you don't have any symbol now. Okay, you have consumed 1 1. This 1 1 you have consumed your string. So yes, I can say here you will terminate. Yes or no? Here I can say you will stop. And you can notice you are finishing in the non-final state. This Q3 is non-final state. You are finishing in the non-final state. Okay, so I can say this is one path. Remember, this is called one computation. This is your computation 1. This is your computation number 1. Okay, what is another computation? From Q2, you can take null move. You can go to Q4. You can go to Q4. From Q2, you can take null move. You can go to Q4. Now tell me, from Q4, can you read symbol 1? This symbol 1 is remaining. Here, this symbol 1 is remaining. One symbol. Okay, this symbol 1 is remaining. Can you read this symbol 1 in this Q4? No, you cannot. No, you cannot. Yes or no? So I can say this path is dying. This path dies, abort. Okay, you can call it abort. Agree? This path aborts. You can say that this path is dying. Okay, because you can notice on this computation, you cannot read the entire string. On this computation, you cannot read the entire string. So tell me how many computational paths are there? How many computational paths are there? Only 2. Only 2 computational paths are there. One will finish in non-final state. Okay, one path will go to non-final state. One path will finish in non-final state. In non-final state. Yes or no? One path is finishing in non-final state, that is Q3, in state Q3. And another path that cannot read the entire string also, that will die. Yes or no? Another path will die, or I can say abort. Okay, or I can say no move. Okay, something like this. Is this clear? There is no move on the other path. The other path will die. The other path cannot even read the string. This string is given to you. Okay, this second path cannot read the entire string. Is this point clear? Please tell me. Is this clear? Let me know. Now let's come back to the question. What the question is asking? The question is asking this 10110 that is given to you. Now, let's see all the options. What the first option is saying? There is at least one computation which will finish in accepting state. Is this true? There is at least one computation. There is at least one computation that finishes in accepting state. That finishes in accepting state. Tell me one thing. If this happens, then what can I say about this string? If this happens, tell me one thing. If this is true, if this is true, then what I can say? If this is true, then this string will be accepted, yes or no? If this is true, then this is accepted. Correct or not? This string will be accepted by NFA. Very simple. Okay, this string will be accepted if at least one path takes you to the final state. This we already know. Okay, this string, when can I say this string will be accepted? W is accepted by NFA. When can I say? W is accepted by NFA if and only if. W is accepted by NFA if and only if at least one computation takes you to final state. At least one computation. At least one computation, or I can say at least one computational path ends in a final state at the end of the string. Yes or no? At the end of the string. At the end of W. Okay, so this is what we already know. W is accepted. W will be accepted if and only if at least one computational path will end in final state at the end of W. At the end of W. Okay, very simple. Now, let's see this one. The question is saying there is at least one computation that finishes in accepting state. Okay, here actually, let me tell you, they want to say that finishes in accepting state. They basically want to say that at the end of the string. Okay, yes or no? If you read the question, you can understand what the question is asking. If you read the question, you can understand what the question is asking. The question is simply saying that there is at least one computation that finishes in accepting state. Okay, means at the end of the string, you are in accepting state. At the end of the string, you are in accepting state. Okay, so tell me, is there any path which will take you to final state for this string 10110? Okay, let's check. I'm checking option A. Only this option. My focus is on this option. Okay, so forget about the remaining options. Forget about them. Okay, so let's see. Can you go to final state at the end? Your string is 10110. Okay, let's see. I want to go here. This is where I want to go. From the initial state, I cannot take this, yes or no? From the initial state, I cannot take this. I cannot take this. I have to take this. I have to take this. Then I have to take this. So one symbol is gone. Yes or no? Agree? Do you agree? One symbol is gone. One symbol is gone. One symbol is gone. Okay. After that, there are two paths. There are two paths. Tell me, if I go on this path, if I go on this path or if I go on this path, on which can I go to this path? The next symbol is 0. This is the next symbol. The next symbol is 0. I cannot take this path. Right? Yes or no? I cannot take this path. I have to take this. Then I have to read 0. Now this 0 is also gone. Now this 0 is also gone. Next symbol is 1. Next symbol is 1. Next symbol is 1. I cannot take this. Next symbol is 1. I have to take this. I have to take this. This symbol is also gone. This symbol is also gone. Next symbol is 1. Next symbol is 1. If I go on this path, can I read 1? Next symbol is 1. Next symbol is 1. If I go like this, I cannot read 1. Yes or no? See, if I take this, then here I will stuck. Here I will die. Yes or no? If I take this, then what will happen? Then here I will die. Agree? Okay, so I have to take this. Agree with me? See, if I take this, here I will die because the next symbol is 1. Okay, so I have to take this one. Okay, now this symbol is also gone. Now the last symbol is 0. Now this is the final symbol remaining, and I am here. I am here. Okay, the last symbol is 0. Can I read 0? Can I read 0? Can I read 0? No. Can I read 0? No. So you can notice, can I go to final state? Tell me, can I go to final state? The question is asking, there is at least one computation which will go to final state, which will finish in final state. The answer is no. Yes or no? The question is saying there is at least one computation which will end in final state, which will go to final state. There is at least one computation which will go to final state. The answer is no. Yes or no? The answer is no. So you can notice this string is accepted or rejected. This string is accepted or rejected. Yes, this is rejected. I can say this is rejected. Okay, this string will be rejected. So you can see this is actually correct. Okay, so this is actually false. And this is actually true. What about the next? What about the next one? Tell me, what is the next? The next is saying there is at least one computation which will finish in rejecting state. There is at least one computation which will finish in rejecting state. Is this true? Which will finish in rejecting state. There is at least one computation which will finish in rejecting state. So tell me, which computation will finish in rejecting state? Your string is this 10110. Okay, you are starting from here. Now tell me, you are starting from here. Now I want that computation which will finish in rejecting state, means at the end of the string, you must be in reject state. Is this clear? What we want? Please tell me, is this clear what we want? At the end, you must be in reject state. Or I can say non-final state. At the end, you must be in non-final state. Okay, at the end, you must be in non-final state. At the end, you must be in non-final state. Is this possible? Is this possible that at the end you are in non-final state? Okay, let's check. So you can see, if you read symbol 1, then for that you have to take this. You cannot take this. You have to take this. This symbol is gone. Next, after that, you cannot take this. You have to take this. You have to take this. This symbol is gone. Next, after that, you cannot take this. You have to take this. You have to take this. This symbol is gone. Okay, after that, if you go here, you will die. Yes or no? If you go here, you will die. Agree with me? If you go here, you will die. If you go here, you will die. Okay, what about this one? Yes, this you can read here. Okay, now what? Now what? Now what? Tell me. Now what you can do? So I can say you can never end. I can say at the end of the string, you can never go to. Basically, actually, if you notice one thing, you can never read the entire string. Yes or no? You can never read the entire string. You can never read the entire string if you notice. Okay, it is not possible to read the entire string. After this one, now you are here, you cannot read the entire string. I can say that you can never read this. We can never read. Agree with me? Okay, yes or no? This symbol, this entire string we can never read. This entire string we can never read. We can never read this entire string. So remember this W10110, we can never read this entire string. We can never read entire W. Entire W. Okay, yes or no? We can never read this entire W. So remember, yes, W will be rejected. W will be rejected. But you can notice, if you notice, all the paths are dying. Yes or no? All computations, they die. So can I say all computations abort or all computations die? Yes or no? All computations, they die. Every computation will actually die. Okay, for this string, every computation will die. So this string will be rejected, but every computation will die. Okay, no computation will I can say no computation will go to final state or non-final state at the end of the string. No computation. Okay, no computation will go to final state or non-final state at the end of the string. There is no such computation. So you can notice there is at least one computation which will die. Yes, this is true. There is at least one computation that will die and you will reject. So the answer will be these two. Is this clear? Please tell me. The question is asking which statements. The question is asking how many statements are true. How many statements are true? So the answer will be two. Two statements are true. Which of them? Okay, this statement is true. This statement is true. And this statement is true. So these two statements are true. Please tell me, did you understand? Let me know. This is a nice question. Tell me the answer. Tell me, did you understand? Tell me, did you understand? Please tell me. See, one thing I want to tell you. If this question comes in the GATE exam, okay, I think they will also mention here, they will also mention at the end of the string. Okay, this is what I want to tell you. If this question comes in the GATE exam, then I think they will also mention at the end of the string. Okay, they will also mention at the end of W. Is this clear? At the end of W. Okay, so you can see at the end of W. Is this point clear? Please tell me. If this question comes in the GATE exam, then in my opinion, okay, I think that they will mention this also. Okay, in this option A, option B. In this option A, option B, they will mention at the end of W. At the end of W. Okay, so very simple. Okay, I hope this point is clear. Okay, what about this third statement? There is at least one computation that dies. There is at least one computation that dies. Yes, this will happen, right? See, you are starting in the start state. Here you are starting. There is at least one computation will die. At least one computation will die. For example, you can take this symbol. Okay, let me call the states. Let me call the states. Let me call it A, B, C, D, E, F, G, H, I, J, K, L. Okay, so let's see. So you can see you will start in the start state. In the start state, you only have one choice. Yes or no? In the start state, how many choices I have? Tell me. In this state, how many choices I have? My string is 10110. How many choices in this start state? Only one choice. Only one choice. You have to go to state A, state B. Yes or no? You have to go to state B. So there is only one choice. What about this state B? Again, there is only one choice. You have to go to state D. Now, where now you can notice now you have multiple choices. Yes or no? You are in state D. See, you are here. You are in this state D. Now you have multiple choices. You are in this state D. Sorry, not multiple choices. No. Okay, you cannot take this. So not multiple choices. From this state D, only one choice you have. Only one choice you have. You will go to C. There is only one choice. You will go to C. Because in this state, you are reading symbol 0. If you read symbol 0, okay, in this state D, you cannot take this path. This path you cannot take. Okay, because your symbol that is 0. So you have to take this path, then you have to take this path. So from C, you are going to E. From C, you are going to E on 0. Okay, now this symbol is also gone. Now you are in the state E. Now where you are in the state E. Now tell me how many choices? You cannot take this. You are in the state E, you cannot take this. So you have to take this epsilon and then you have to go to F. Okay, so from E, you have to go to F. Now, in this F, you have to take this. So from F, you are going to H on symbol 1. On symbol 1, this one is also gone. Next, in this H, now there are two ways. Yes or no? Yes or no? In this state H, now there are two ways. Now, in this state H, you are in this state H. In this state H, this is your symbol on the input tape. Your input tape has this symbol. You are in this state H. Your input tape has this symbol. Now tell me how many moves are possible. Tell me. You are in this state H. You are in this state H. How many moves are possible? Your input tape has symbol 1. Your input tape has symbol 1. You are in this state H. How many moves are possible? 2 moves are possible. From S, there are 2 moves possible. Either you can make a null move or you can read symbol 1. If you make a null move, you will go to G. If you read symbol 1, you will go to J. Okay, so there are two moves now. From this state H, if you take a null move, you will go to G. Okay, you will go to G. And if you take this symbol 1, if you read symbol 1, you will go to J. Now from G, what will happen? Tell me. In this G, is there any move possible? Please tell me. In this state G, is there any move possible? In this state G, is there any move possible? There is no move possible. Yes or no? So in this state, you are stuck. Or I can say you are die, or you can say you are stuck. This computation dies. Abort. So remember this computation. Please look at this computation. Look at this computation. This computation dies. Okay, this is a computation. This computation dies. Is this point clear? This computation dies. Okay, look at this computation. This computation, okay, this computation is dying. Okay, I hope this point is clear. Similarly, you can go forward from J. Where you can go? From J. Let's see. From J. From the J point of view. So from this J, if you are on J, then I can say that this symbol is also gone. If you are on symbol J, okay, so then I can say 1 0 1 1. Yes, this symbol is also gone. So in J, how many choices I have? In this J, you are in this state J. Again, there is no move. Again, there is no move. Again, you die. Again, this computation dies. Again, this computation dies, right? In this state J, this is on the input tape. On the input tape, you have 0. You are in this state J. You are in this state J. Okay. On the input tape, you have 0. On the input tape, you have 0. There is no move. There is no move. There is no move. So you can notice this computation also dies. This computation also dies. This computation also dies. Okay, so every computation dies. Is this point clear? Please tell me. This computation also dies. You can notice. Okay, this computation, this path, you can notice this path also will die, and this path will also die. Both these paths are dying. Okay, so this is the idea. Please tell me, did you understand? Let me know. Okay, let's move on now. Now let's see this question. Let's see this question number 7. Question number 7 in this weekly quiz 26. This question is also taken from Stanford. Okay, you can see this is also taken from Stanford. Let's see what this question is asking. The question is saying we transform the following NFA to equivalent DFA using the subset construction. Okay, this NFA is given to you. You can note this NFA is given to you. We are converting this NFA to equivalent DFA. Okay, this NFA we are converting to equivalent DFA using subset construction, using power set construction algorithm. The question is saying, what should this row look like? The question is asking this row. Okay, yes or no? What this row will look like? What this row will look like? This third row. What it will look like? What it is going to look like? So from this Q0, Q2, okay, just focus on this Q0, Q2. Focus on this state Q0, Q2. Tell me, from this state Q0, Q2, if you read symbol A, then what you need to do? If you read symbol A, then tell me where you will go. From this state Q0, Q2, if you read symbol A, where you will go? See, in this NFA, there is no null move. In this NFA, there is no null move. If you notice, there is no null move. Yes or no? In this NFA, there is no null move. Okay, so you can very easily do. From this state Q0, Q2, on symbol A, where you will go? Where this state Q0 will go? Where this state Q0 will go on A? Q0 will go to Q0, Q1. Okay, Q0 will go to Q0, Q1. And where this Q2 will go on A? Where this Q2 will go on A, that will go to Q3. So your final answer will be Q0, Q1, Q3. Okay, so I can say Q0, Q2. From Q0, Q2 on symbol A, from this state on symbol A, you are going to Q0, Q1, Q3. Okay, what about symbol B? What about symbol B? From Q0, Q2. From this state Q0, Q2, on symbol B, where are you going? Where this Q0 will go on symbol B? Where this Q0 will go on symbol B? On symbol B. This Q0. Remember, this means A, comma B. This means A, comma B. So this Q0 on symbol B, it is going to Q0. It is going to Q0. Where this Q2 is going on B. Where this Q2 is going on B. Q2 is going on B. Nowhere. Okay, so I can say on B, finally you are going to Q0 only. Okay, yes or no? So this is your final answer. So what will be the final answer? Tell me. You can see. What will be your final answer? Your final answer. You can see this is your Q0, Q2. Means this row. The question is asking this row, third row. The question is asking this entire third row. Okay, so you can see Q0, Q2, that is same. Next, after that, yes, I can say answer will be option C. Option C will be the answer. Yes or no? Your answer will be this. This will be your answer. Okay, so this is also very simple question. Now, let's move on. Now, let's see this question. The question number 8. The question number 8. Okay, this is also taken from Stanford. All the questions, these are taken from Stanford. You can see all these questions. So you can see this question number 8. This question, what this question is asking? This is asking, we transform the following NFA into equivalent DFA using subset construction. This NFA is given to you. We convert this NFA to DFA using subset construction. Okay. And what the question is asking, what this row should look like. The question is asking this row, what this row should look like. Okay. This is what this question is asking. So you can see, this is also taken from Stanford. Question is also very simple. This NFA is given to you. You can notice this NFA is given to you. Okay. And we are converting this NFA to DFA. This NFA we are converting to DFA. This is our DFA. We are getting a DFA, equivalent DFA we are getting using subset construction algorithm. The question is asking what this row should look like. This third row. These are the 4 options. You can notice what this row should look like. Tell me one thing. Do we have null move here? In this NFA, do we have null move? In this NFA, do we have null move? Yes, there are null moves. Yes or no? In this NFA, there are null moves. Okay, there are null moves. So you should take care. Whenever you have null move, okay, so always take care. Whenever you have null move, so always take care. Okay, just take care. Okay, let's see. So tell me, from Q2, Q3, your state is Q2, Q3. Let's see. From this state Q2, Q3, this is your state. Okay, I want to know where you will go on symbol A. From this state Q2, Q3. This is your state Q2, Q3. From this state on symbol A, where you will go. So tell me what you will do. On symbol A, where you will go, what you will do? First, you will check. See, either you can do this. First you do this, then you do this, then you do this. Yes or no? But if you remember one thing, I told you this is redundant. Do you remember? Okay, do you remember? I told you this step is redundant. I told you this is redundant. Okay, this is redundant. Okay, if you remember, I told you that this is redundant. Of course, you can do this. No problem. No problem. You can do this, but this will be redundant. Okay, the same thing you will get here. You can check it. The same thing you will get here. You can check it. Tell me where this Q3 will go without reading any symbol. What is the null closure of Q3, Q2? What is the null closure of Q2? What is the null closure of Q2? That is, I can say Q2 will go to Q2 only. Okay, where Q2 will go for free. This state Q2, where it will go for free. It will go to Q2 only. Without reading any symbol, where Q2 can go to Q2. Okay, where Q3 can go without reading any symbol, where Q3 can go to Q3. So you can notice, I told you this is redundant. Yes or no? This first step is redundant. So remember this point you remember, you don't have to do this epsilon A epsilon. See this epsilon, A epsilon, you don't have to do this. You don't have to do this. You can directly do A epsilon. Yes or no? You don't have to do this because this will be redundant. This will be redundant. You can directly do this. Tell me one thing. If you do this, is it wrong? If you do this, is it wrong? If you do this, is it wrong? No, this is not wrong, but this is redundant. Okay, this is not wrong. This is also correct, but this first step is redundant. Okay, so that is unnecessary. Okay, now let's see this. So tell me, this A, just look at the ages. Okay, just look at the age A. Only look at age A. Okay, only look at age A. When you are checking this, then only look at age A. Okay, so very simple. Only look at age with symbol A. So tell me where Q2 will go on A. Where this Q2 will go on A. From this Q2, where this Q2 will go on A. Remember this sigma means A comma B. Okay, this sigma, what this sigma means? This sigma means A comma B. Similarly, this sigma means A comma B. So where this Q2 will go on A? Q2 will go to Q0. Yes or no? Q2 will go to Q0. This Q2 will go to Q0. Where this Q3 will go on A? Where this Q3 will go on symbol A, it will go to Q4. It will go to Q4. Okay. Now, where Q0 will go for free? Where Q0 will go for free? This state Q0, where it will go for free without reading any symbol, without reading any alphabet symbol, where it will go? This Q0, for free it can go to Q0, for free it can go to Q3. So for free it can go to Q0, Q3. Okay, where Q4 will go for free? This Q4, where it will go for free? It will only go to Q4. Okay, so your answer will be what? I can say your answer will be Q0, Q3, Q4. Q0, Q3, Q4. Okay, Q0, Q3, Q4. Yes, so the answer will be option A. Yes or no? So the answer will be option A. These are wrong. Okay, so like this you can do. So finally, in this question, your answer will be, I can say option A will be the answer. Of course, you can check. See, these options are eliminated. These options are eliminated. But of course, you can check for B. Okay, let's check for B. Let me check for B. Then what I will do? I will check this and then I will check this. So this is what we are going to do. Okay, so let's check this. So tell me, when you are checking this B, then only look at age. Only look at age. Okay, so just look at age B. That's it, nothing else. Okay, so let's see this. So tell me, Q2, where it will go on B? Where this Q2 will go on B? Q2 on B. Q2 on symbol B will go to Q0. Okay, so that will go to Q0. And where Q3 will go on B? Q3 on symbol B. Q3 on symbol B, it will go to Q4. Okay, next Q0 for free. Where Q0 will go for free? This state Q0, without reading any alphabet symbol, it can go to Q0 or it can go to Q3. It can go to Q0 or it can go to Q3. Where Q4 will go for free? This Q4, without reading any symbol, it can go to Q4 only. Okay, so that's it. So you can easily notice your answer will be option A. This will be your correct answer. I hope this point is clear. Okay, so this is another question from Stanford. Very simple. Now let's see this question. Question number 9. This is also taken from the Stanford. So tell me the answer. You can see this. Question is given to you. Okay. What this question is saying? The operator precedence is given to you. We already know. Yes or no? This operator precedence, we already know that bracket has highest priority, then concatenation, then okay, bracket has highest priority, then star, okay, then star, then this clean star, then this concatenation, and then this OR. Okay, so these are the priority order. Yes or no? This is the priority order that is given to you. Now, this question is saying that this is the order of priority from highest to low. Consider the regular expression. This regular expression is given to you. This regular expression is given to you. So actually there is a mistake here. There is a mistake here. Okay, this is actually, there is a mistake here. This should be A, B star C union D. Okay, so there is a mistake here. I will correct it. This is the mistake. Okay, so in this expression, there is a mistake in this expression. This expression is actually this. Okay, so I will correct it. You can read here. Okay, you can see this in this Stanford slide. You can see. So this is correct. Okay, A, B star C union D. Okay, according to this, tell me the answer. Okay, tell me the answer according to this. Tell me the answer according to this. So you can see your regular expression that is given to you, that is A, B star C union D. Okay, this is the regular expression. This is the regular expression that is given to you. Okay, you can easily notice that this will have more precedence. Yes or no? So it's like this. So tell me, what is your language? What is your language? Your language has D. Your language has this D. Your language has AC. Your language has ABC. Your language has ABBC. Your language has ABBC and so on. This is your language. Yes or no? This is the language. So the question is asking, how many strings are described by this expression? How many strings are described by this expression? So I can say, yes, AC is described. This is not described. ABABC, that is not described. ABCD, no. So the answer will be only one. The answer will be only one. Okay, answer will be option this AC. Okay, so the answer will be only one. So for this question, you can notice the answer will be only one. Only this is described, nothing else. Okay, let's move on. Now, this is our question number 10. So tell me the answer. Question number 10. This is another very simple question. Okay, so you can see from the Stanford. Now, the question is saying this alphabet is given to you. This language is given to you. What is the language? The language is strings which contain at most one A. Strings which contain at most one A. Strings which contain at most one A. Okay, so I want strings. Remember, my alphabet is A, B. This is my alphabet. I want strings which contain at most one A. So what I can do? Contain at most one A. Okay, so here what I can do? Containing at most one A, that simply means I can say your idea number one. What is the idea number one? See, idea number one is like this. No A. Okay, no A or exactly one A. Yes or no? No A or exactly one A. Agree? Okay, so this is the idea number one. Idea number one is this. No A or exactly one A. If there is no A, then what is the regular expression? What is the regular expression if there is no A? That is B star. And what is the regular expression when you have exactly one A? Exactly one A. When you have exactly one A. So here what you have? If you have exactly one A, so here you have B star and here you have B star. Okay, so your answer will be what? This is your OR. Okay, and here you will get B star A, B star. So your answer will be this. Agree? Correct? Okay, very simple. Exactly one A, not more than one, not less than one, exactly one. Okay, so if this is your exactly one A, then here you have B star, here you have B star. So this is your idea number one. What is idea number two? What is idea number two? See, containing at most one A. Containing at most one A. Idea is this. Somewhere, either there is A or there is epsilon. Yes or no? Do you agree with me? Agree with me? See, containing at most one A. Containing at most one A. Containing at most one A. So somewhere, either there is A or there is epsilon. Here you have B star, here you have B star, here you have B star, here you have B star. Please tell me, will it give me at most one A? Will it give me at most one A? Please tell me, will it give me at most one A? Yes, it will give me at most one A. Why? Tell me what is the reason. See, If you want no A, then what you will do? If you want no A, then what you will do? If you want no A, then what you will do? Then you will take this. Then you will take this. And if you want exactly one A, then you will take this. Okay, so your answer will be what? That will be B star. Okay, here either you have this or you have this followed by B star. If you notice, this is same as your idea number 1. If you notice, you will get the same answer. If you notice, you are getting the same answer. Yes or no? If you notice, you are getting the same answer. Idea number 1, idea number 2, they are giving you same answer. So tell me the answer. Tell me the answer here. What about this one? What is the language here? Sigma star, A sigma star. Tell me, what will be the language for this option A? Sigma star, A sigma star. That means A or B whole star, A or B whole star. Correct? Tell me, what is the language? Let me know, what is the language here? The language is containing at least one A. Yes or no? The language is containing at least one A. Containing at least one A. This is your language, containing at least one A. So I can say this is not the answer. Definitely this is not the answer. What about the second one? Yes, second one is the answer. What about the third one? Yes, third one is the answer. What about the fourth one? What about the fourth one? Tell me. What about the fourth one? See, fourth one can create more than 2 A's. In this, what you can do? In this, what you can do? What you can generate? Tell me. In this, what you can generate? You can generate this type of string also you can generate. This string also you can generate. So I can say this is also not the answer. What about option E? What about option E? In this option E, what you can generate? Tell me. In this option E, what you can generate? What you can generate in this option E? In this option E also you can generate this. This string you can generate. Okay. So like this. I hope this point is clear. So tell me what is the answer for this question? For this question, your answer will be option A is not the answer. Option B is answer. Option C is answer. Option D is not the answer. Okay. So for this question, answer will be B, C. This will be your answer. Okay. So please tell me, did you understand so far all the questions? All the questions, all these questions, did you understand? Let me know. So far, question 1 to 10. Question 1 to question 10. Did you understand? Let me know. All these questions. Anyone has any doubt in this? Let me know. Anyone has any doubt from question 1 to 10? We will see question 11 to question 15 in the next session. Okay. So let's create a next new session after breakfast. Okay. So you can have a break. I think 45 minutes break you can take, or maybe we can start at 1 p.m. and we can complete it. Okay. Question number 1 to question number 15. We can start a new session at 1 p.m. We can start a new session and we can complete, so that today this quiz will be over. Okay. So a new session I will create at 1 p.m. and these remaining 5 questions also we will discuss. Okay. So far, anyone has any doubt? Let me know. Did you understand? Please tell me. Okay. So see you at 1 p.m. Thank you.